In further maths, the polynomials that we have to deal with when we're making use of Vietas formula, at the moment they only go up to the power of 4, so degree 4 or degree 3. This section is about polynomials of degree 2, and it's just kind of an introduction section. You're unlikely in your exam to get polynomials of degree 2, but they can still be useful to give us a little bit of an intro to how these Vietas formulae can be used. So if we have p of x equals ax squared plus bx plus c, and then by the fundamental theorem of algebra we can write it as a times x minus r1 times x minus r2, then by Vietas formula we have that r1 plus r2 is negative b divided by a, and r1 times r2 is c divided by a. And our first exercise of this section says that the roots of 2z squared plus 7z minus 2 equals 0 are alpha and beta. And using Vietas formulae, find a quadratic that has the roots 2 alpha and 2 beta, and 3 alpha minus 1 and 3 beta minus 1. Now obviously we could use the quadratic formula and find alpha and beta pretty quickly, but that's not what this section is about, and for the questions you get in your exam, it's not going to be easy to do that. So it's going to be much easier to make use of Vietas formulae. So that's what we're going to do here. And by Vietas formulae, we know that negative 7, so negative b divided by a, so negative 7 divided by 2 is equal to alpha plus beta. And we also know that c divided by a is equal to alpha times beta. So that would be negative 2 divided by 2 is equal to alpha times beta. And so that would actually equal negative 1. Now we're looking for a quadratic equation that has roots 2 times alpha and 2 times beta. And so any of those quadratic equations will do. So we can use Vietas formula again to get the middle coefficient. We can find 2 alpha plus 2 beta. So 2 alpha plus 2 beta is equal to negative b divided by a, and since alpha plus beta is negative 7 divided by 2, then we know that that's going to be equal to negative 7. So negative b divided by a equals negative 7. And then 2 alpha times 2 beta is equal to 4 times alpha beta, which is equal to c divided by a, and that's equal to negative 4. And since we're looking for any quadratic that has roots 2 alpha and 2 beta, we can choose our value of a. So let's take a equals 1, which would then force b to equal 7, and then that would also make c equal negative 4. And so our quadratic equation is z squared plus 7z minus 4 equals 0. So that must have roots 2 alpha and 2 beta. Okay, let's move on to the second part now, which is also pretty easy. 3 alpha plus 3 beta minus 2, which is the sum of these two. That should equal negative b divided by a, and it's also equal to negative 21 divided by 2 minus 2. So 3 times alpha plus beta minus 2. And as a fraction, what's a nice way to write that? Minus 25 divided by 2. Okay. So negative b divided by a is negative 25 divided by 2. And now we need to find our c divided by a. So c divided by a is equal to 3 alpha minus 1 times 3 beta minus 1. And expanding that out, we can get 9 alpha beta minus 3 times alpha plus beta, and then plus 1. And we know that alpha beta is negative 1, so negative 9 minus, this time plus 21 divided by 2, and then just plus 1. Cool. Okay, and by my calculations, that is 5 over 2. And so we have C over A is 5 over 2, negative B over A is negative 25 over 2. So to me, it makes sense to make A equal to 2, B equal to 25, and C equal to 5. So that would give us 2z squared plus 25z plus 5 equals 0. So that's our quadratic equation with roots 3 alpha minus 1 and 3 beta minus 1.